I'm going to teach you how to make your own functions today. It's going to be great. But first, I would like to talk to you about a different kind of loop. It's called a for loop. All right. So we learned about one kind of a loop in Python already called a while loop. For loops are just as powerful. So if you just want to not pay attention for the next 5 minutes, that's fine. But I promise that they're useful, even though they're technically equivalent in power to a while loop. They give you nothing new, but they just make your life easier. Equivalent in power to the while loop that you already know. So anything you can do with while, you can do with for. Anything you can do with for, you can do with while. You might have to change things up a little bit, but there's always a way. Okay, so what a for loop does is, instead of while, you say the word for, first of all. What it does is it iterates, it goes through, right? It goes through things that are iterable. All right, that's a weird thing to say. The one thing that we know in this class that is iterable, that has things to be gone through, is a list. All right, so you can just pretend, when I say iterable things, you can just think of everything that's iterable as a list, building up a list somehow. But if you have a list, L equals, 4, 5, 6, a for loop gives you a way to go through each element and visit them in order from left to right. So instead of a while loop where you did indices, go to index 0, then 1, then 2 in that order, you could make it a little bit better with a for loop. It's a little bit easier, I would say. So here's the syntax. Here's what it looks like. You say for, and then you give a variable name. I'll call it x, let's say. And then you say the word in, because you're going through something. What's the thing you want to go through? And then you give some iterable thing like a list. So for x in L, colon, that's the first line. Then you tab over, and then you put the body of your for loop. Body goes here, whatever you want to do each time it runs. All right, and what's going to happen is, as many lines as you need, what's going to happen is this variable will be set to each element of that list L in order, and it will run the body as many times as there are elements, which is really nice. It'll go through from left to right. X gets a chance at being 4, it runs the body. It gets a chance at being 5, runs the body again. It gets a chance at being 6, it runs the body, and it stops. Okay, so it's 4. That's how I kind of think about it in my head. For everything, call it X in L, I want to do this for each of those things. Kind of how you read it. So let me show you that as an example. Let's open up idle. And I'll make a new folder for today. Let's see, what lecture are we? I will figure that out in just a second when I change the sizes of these things. We are apparently lecture number 23 today, so I'll make a new file for loop stuff, and I'll save it in a lecture 23 folder. And what should I call this? I'll just call it for loop stuff. And so let's do exactly that. Let's make a list, L. It's an iterable thing you can go through. L equals 4, 5, 6, let's say. Got a list of numbers. And, all right, I'll say for x in L, colon, and then it indents automatically. I can do stuff with x. All right, when you're in the body here, x gets a chance at being everybody in L. X gets a chance to be every element in L in order from left to right. Right. So the first time it runs the body, x will be set to 4. The next time it will be set to 5. The last time it will be set to 6, because that's the order and the things that are in the list L. That's pretty nice. So I'll just have that. We'll print everything. Every time we have a new number to look at, we'll print it out. So this should print 4, 5, 6. And that's what we see. And if the list was different, of course, if there was more things in it, 4, 5, 6, 7, then of course x would get a chance at being the 7 too. See how it's going to print them all out regardless? Let's see. Yeah. Any questions about this? Because a for loop, it's going through every element in L. We're going to call that thing x each time, and we're going to do something with that x. Does that make enough sense? So you could totally do this with a while loop. It's just slightly more complicated. Right? So one thing that you normally want to do a lot of, that we did a lot of with while loops, is go through some numbers, iterate through some numbers, iterate through a range of numbers. So There's a nice built-in function in Python called range. You can either give it one argument or two arguments. It also takes three if you look into it. It will create an iterable thing. You can think of it as a list that just makes that range. So this is a built-in function. You don't have to import anything. Just use it like len, for example. So yeah, you say range. Say range something. So let's say I want to make a list of numbers to go through. I want to go through the numbers 1 through 10. Like if I want that range, 1 through 10, 1 to 10, the way you get it is you say range, and what it does is it produces, if you give these two arguments, you give it a starting value and then you give an ending value, and it creates a range starting at the starting value but going up to the ending value minus 1. Sadly, it's always strictly less than the ending value. So it's creating this kind of range. If you've seen the syntax before from a math class, like starting val inclusive, ending val exclusive. That's what it's building for you. So we'd call, if we wanted to make that range, we'd call range not 110, because that would go from 1 to 9. We call it range 111. That would make the numbers 1 inclusive all the way to 11 exclusive. Okay? So yeah, let me show that to you in the REPL. That's a really nice thing. It's a way to make a bunch of numbers, and you can go through them with a for loop very easily. So if you say range 111, sadly, all it gives you back is range 111. Like it's not really a list. It creates some iterable thing that a for loop understands. But if you want it to be a list, you can convert it and say like, all right, range 111, show me you as a list. You can say, make a list out of that thing. And so it really does create the list 1 through 10 there. Okay. You can also give just one parameter to range if you want the starting value to be 0. So if you just say range up to the ending value, if you just give one argument, that will create a range that starts at 0. So maybe if you wanted a range from 0 to 100, you could call range just with one argument, and you'd give it not 100, right, because that would go up to 99. You give it 101. Okay, so let me prove that to you. So make a list out of range up to 101. That's all the numbers from 0 to 100. Questions about that? So you can use range in your for loop, which is nice. So let me show that to you. So kind of here's the strategy. If you want to just like go through a bunch of numbers and do something with a bunch of numbers in order, you can be like, what have I done? Let me make some space here by just putting an empty line. And you can do something like this. You can say like, for every y in range 1 to 11, right? So that's the numbers from 1 to 10. And we'll call all of those numbers y. They'll all get a chance, right? Range is an iterable thing. We'll print y. So this code is going to print the numbers from 1 to 10. Does that make sense? Like it's going through the range from 1 to 11, which we know is creating the list essentially from 1 to 10. Y gets a chance of being all those things. We're printing y each time. So there it is. There's my 1 to 10. So that's a very easy way to go through a bunch of numbers. Just like for that, give a variable name in range, whatever you want. Okay, that's pretty nice. So let's see, what do I want to do? Let's do something other than printing. How about we add up all the numbers from 1 to 100 or something. So it's a simple thing to do with the for loop, right? So let's iterate through all the numbers between 1 and 100. Think about which range that's going to be, right? Which range call would that be? And we'll add them into a sum variable each time. So I'll start a sum variable at 0, and then I'm going to loop through every number from 1 to 100. So for every number, I've used x and y already. How about I use z this time? For every z in the range, how do I get all the numbers from 1 to 100? Well, 1 is the starting value, and the ending value, it's always up to that one, but not exactly, right? It's always up to, but not inclusive, so I want to go to 101. That'll produce all the numbers from 1 to 100. So for every z between 1 and 100, what do I want to do with it? I want to take it and add it into sum. So sum will have been increased by whatever z was. Z gets a chance at being all the numbers from 1 to 100. So I'm adding 1 in the first time, 2 in the next time, 3 in the third time. Sum just keeps on increasing. And by the time that loop is done, you've used up all those numbers in that range, and sum is a variable with the right sum in it. So apparently the sum of all the numbers from 1 to 100 is 50/50, which is a cute little number. So yeah, that's something you might want to do. Just imagine how you would do that with a while loop, right? You'd have to make like an iteration variable, I or something, start it at 1, while it's less than or equal to 100, do all those things. Like the range is taking care of a lot of things for you. It's pretty nice. Okay. Any questions about why this program on the left makes this output on the right? Not too horrible. All right. Now, without any further ado, I want to teach you how to make functions. It's going to be great. So I want to teach you how to make your own functions, just like you've been using all these library ones. How do you make your own to do whatever you want to do when you call it? Okay? So let's remember. All right, so the equivalent of functions in Scratch was when I told you how to make your own blocks. And there are a lot of similarities, okay? So essentially, when you made your own block, they took, like, you ran that block in many different places, potentially, and every time you ran the block, it jumped up here to the definition, and it set whatever you passed along into this variable, and then it did stuff potentially with that variable. Okay, that's how it worked. The technical terms are parameters and arguments. Okay, so when you use your function, you're passing along things called arguments, right? That was the name of those things. Those are arguments. And then in the definition, you're using parameters, all right? The parameter in the definition is getting the argument from the call. It's being placed. It's being placed up into here when you call the function, okay? That's how that's working. And that is supposed to be an M there. All right, so functions or blocks take a parameter in the definition. You give arguments each time you use it or call the function, okay? So you already know how to call functions in Python. You say its name, give some parentheses, give some commas for all the arguments, and then maybe you give an answer back. If there's an answer that's given back to you, you need to save it or use it in some way. And so like range, like we used range just now. The argument, 101 was an argument to range, and somebody in the definition of range was using it, taking it into a parameter somewhere. Okay? So yeah, if we want to make our own functions, like range or something, we want to make our own version of range, maybe, we need to think of a name for it, of course. We need to give names to the parameters, the things that it's taking when it's being called, because we need to do stuff with those. And then we need to give a body. What do we want to have happen when we're given those parameters? When somebody calls us, what do we do? Okay, that's pretty much what goes into thinking about a function. So let me show you how to define a function. I guess I showed you last time in a cheating way, but this is the real lecture on it this time. So to make a function, to define a function in Python, you say def, right? So def marks the start of any function definition, and then you give the name of that function, so like whatever you want to call it. I'll call it func name. Same rules for variable names apply to function names, so you can call it whatever you want. And then you give parentheses, kind of like pretend it's being called almost. And then what you give is you give all the names of your parameters, all the variables that will hold the things that people give to you when your function gets called. You can call them whatever you want. I'll just call them like P1, P2. You can comma separate as many ones as you need. Potentially your function doesn't even have any parameters. It's fine to have functions without any, but these are called parameters. These are the things that control how your function executes. All right, they're variables, essentially. And then you give a colon, just like anything else. And then you tab over, and then you give the body of your function. So body goes here in the indented part. And essentially what you do is you've been given these things. Somebody gave you some numbers or whatever, and they got placed into these variables called your parameters. What do you want to do with them? That's what you do in the body. Okay? You act on those things. All right? So you say how to use the parameters to build up an answer. And then the goal of like making a function, the whole point of making a function is that you can call it potentially a ton of times. Right? So the way that you're going to call your function is you say func_name, and then you give it as many arguments as it had parameters that it needed. So 42 and 43 maybe, if it had two parameters, those were the arguments that will be passed along. So like the 42 will get passed into the P1, the 43 will get passed into the P2, and that starts running the body with those exact values. Okay, so you're always going to have something concrete eventually, but that is the key here. All right, the values of the parameters in your function definition are going to be set to the values of the arguments. right? So the parameters, again, names of the variables in the definition, they're always variable names. And the arguments can be whatever, just like whatever you want to pass along. And when you make the call, when you call this function and it goes off and it does its work, it's going to be passing along 42 into the first parameter. 42 is the first argument, it's going to be passed into P1. 43, the second argument, is going to be passed into the second parameter, P2. And it starts running the body with those values. You can access them with P1 and P2. Okay? So, yeah, that's the idea. Some functions don't need any arguments, and so you don't have any parameters, but a lot of them do. All right? So I hope that makes at least a little bit of sense. Let's give a bunch of examples. I think that's going to help. So let's do the simplest function I can think of. Let's make a function that prints out all the numbers from 1 to n, right? Where n is something that the user supplies to us. Okay, see where I'm going with that? So like we're going to need a parameter and we'll call it n. So for example, if we can call it this, right? We'll call it like print from 1 to, and then the user needs to supply something here, like 5. So that's how I want to use the function. That's the name I want to use, and that's how I want to be able to call it. And what should it do when I call it? Well, if I called it with 5, it should print all the numbers 1, 2, 3, 4, 5. Yeah. That's my goal. There. So, all right, we must define the function now. Let's give it a name. Let's give it a definition block. So I'm going to say def, name of the function, print from 1 to, and then just as it's going to take one thing, I need to give one parameter. I need to give a name to the thing that I'm being given every time somebody calls me, and I'll call it n. All right, print from 1 to, call it n. And then I'll give my body whatever I want to do with that n, okay? And we do stuff with the n every time I get called, so like we can loop and we'll print stuff, it'll be fine. But the secret, what I want to tell you, is like whenever you call a function, what happens is Python goes straight to, it jumps straight to the code, straight to the body in the definition, all right? And it sets the values of the parameters to the values of the arguments. So like n is essentially a variable. When you call this function, it's going to jump to here, to this code, and it's going to set the n to 5, okay? It's going to set the n to 5 because that's what you passed. It's just a special kind of variable. You can think of parameters like that. So that's what n is. So it's just a variable that exists for the life of that function call. It's like what you gave here. It's going to be passed along into that thing. So n goes away once the function returns, once the function's over. So n only exists inside the function. Okay? That's the idea. I hope that makes at least a little bit of sense. So let me show that to you, all right? I said a bunch of words. Now let me try to get across what's happening with a real example. Let's actually code this up. So I'll make a new file, I think. What should I call it? I'll call it functions. Functions.py. And here, what do I want to be able to do? I want to be able to call it like this, like print from 1 to 5. I want to be able to call it a bunch of times, print from 1 to 10. And that's like a different value. Maybe I can like separate it with some, like a line of spaces or something. But that's how I want to use my function. And so let's go off and let's define it. So def, I want a function called print from 1 to, and it's going to be given one argument, so I need to have one parameter. What's the name of the thing that I'm given? I'll call it n. And then, all right, now you tab over and we get to say stuff about n now. We get to use n here to print from 1 to n. And the goal is to understand that n is different every time. Like if you say print from 1 to 5, n is going to be passed along and holding 5. When we jump up here, when we call it here, we passed along 10. 10 is going to be placed into n, and we're going to use 10 as n. Okay, it's going to be, that's why it's a variable, because it varies depending on what you give when you call it. So, all right, how do we print all the numbers from 1 to n? We can use our for loop. I know. So I say for every x in range 1 to, not n, right, because that would print from 1 to n minus 1. I can do it like this. For every x in range 1 to n plus 1, because it's exclusive for the ending value. Print x. All right. So that's going to be the secret. A lot of things building on top of each other. And so now, the first time I call it, it'll jump to here with n being 5, and so it'll make the range from 1 to 5, print every number, and then when I call it again, it'll jump back here, set n to 10, and it'll make the range 1 to 10, right, and print that out. So there it is. I'm calling it twice, and it's doing the correct thing both times. Are there any questions about that? That's like the full picture. That's pretty cool. That's super powerful. So like if you have something you keep doing a bunch of times, like drawing squares or drawing triangles, you can package that into a function. That's a good thing to think about. Okay, so that was a function that was meant to be called just by itself, right? Meant to be called just by itself, and it goes off and it does something for us. There are other kinds of functions, aren't there? There are functions that do stuff and then give us back an answer. All right, so like what's a good example of that? Like the square root function, I think would be a good one. So like these functions are meant to be called on a line by themselves. They go off and they print stuff for us. But if I import math and I call math.square root of 2 on a line by itself, this was a useless call, right? Because if I run this program, sure, it's computing the square root of 2, but I see no output. I haven't used the value. It's giving something back to me. Do you see the difference there? It's really two different kinds of function calls. There's one that just goes off and does something for you, and then there's a function that gives something back, and you better use that. I could wrap it around a print, maybe, or I could store it into a variable, but it's kind of useless to keep it like this. See that? That's important. Yeah, if you want to give something back, if you want to have a function that gives something back and is meant to be used in a larger context, then you use the return keyword in your function. Okay? So yeah, just to spell it out some more, some functions, they go off and do stuff, while others give back results. Like there's a min function. I think you can imagine what min does, right? A min function takes as many arguments as you give it, honestly, and it gives you back the minimum value. So min 2, 3 is going to give back, right? It's going to give back a 2, and so you can kind of imagine like it's going to be replaced with the 2, and that's what you're going to then store into the x variable. So that's kind of how that works. It's meant to be used in a larger context, a function that gives something back. You better put it in a variable, all right? Or like print it, like that would work as well, because like it's not going to do the printing for you. It's just going to compute a value. Min 2, 3, like that's going to compute and give back the answer of 2, and then you can like use it in a larger context, create 3, print it out. Okay, so like it's really going to get replaced. So functions that give back answers like min or like square root, they're going to be replaced with the value they give back. That's how I want you to think about it. Okay, and so they're meant to be used in larger contexts. Like you can say min 2, 3 plus max 2, 3, like that makes sense. Because you can imagine these functions are giving back answers, and they're going to be replaced with their answers. So like min 2, 3 gives back 2, max 2, 3 gives back 3, and so you can like create a bigger expression that computes 5. You see that? So that's pretty nice. Okay, so you can imagine functions that give things back are going to be replaced by the values that they give back, and so you need to use them in a larger context, print them out if you need to. It's not going to do the printing for you, for example, right? Does that make sense? So that's the reason, right, why you can't just call square root on a line by itself. Like, you compute the value, but you haven't used it. It's not printing out. It's like you lost the whatever the value, 1.41, whatever. You lost it. It vanished into the ether because you didn't save it somewhere. Okay? Functions that give something back need to be saved. So that's the first thing I want to say. And yeah, you can wrap those answers in like a print call. The complete opposite of that also doesn't make sense. Like a function called print, right? Our print function is always meant to be called on a line by itself. It makes absolutely no sense to do this, right? X equals the result of printing something. Printing doesn't give anything back to you. You see that? Like, gives nothing back, so it's not going to be replaced with anything. It also makes no sense. Like, it's can't like add the result of 2 print calls. Do you see how that's just weird? Print is a function that goes off and does something for you. It's meant to be called on a line by itself. It gives nothing back. But min, square root, things like that, they give things back. They need to be used in a larger context. If you want to print them, you better wrap them around a print. Something like that. Okay? So that's a lot of words. So yeah. Square root gives something back, you better use it in a larger context. It's incorrect to do it that way. And then also, like, our print from 1 to function just goes off and it prints stuff, right? Print from 1 to 3 goes off and prints stuff for us. It gives nothing back, so it makes no sense to say this as well. So That's a little weird as well. So print from 1 to 3, what does that do? Print the result of print from 1 to 3. So let me try and explain why you see this output. That's what it's producing, this line. It's producing this line. 1, 2, 3, none. Weird. All right, so here's what happens. Print is like, all right, I need a value. I need to print something. I need to get something back from this function call, right? So I need to like compute this answer before I print whatever it's supposed to print. And so it goes off and it calls print from 1 to 3, which does its job. It like prints the values from 1 to 3. And then this function gives back nothing at all. In Python, there's a special keyword that means you gave back nothing, and it's called none. So the result of this function call, it gets replaced with none, and that's what print sees, and then it prints that. All right, so that's the secret there. So the function gives back none when you don't explicitly give anything back. That's like implicitly happening. And so that's why we see this output. And again, it makes no sense to do it like this. Do we see that? So that's the secret there. Let's see, how do I want to do this? So yeah, if you want to make a function that gives something back and is meant to be used in a larger context, you return it. You say return that thing inside of your function. Okay, so let me give you an example of that. So let's make a function called sum. It's going to be a very, very simple function. So it's going to like take two numbers, give back the sum of those two numbers. Could have just used the plus, I know, but this is a good first example. It's like we're going to make a function called sum, and if you give it 2 and 3, it's supposed to give back 5, for example. All right? That's the point. It'll be very, very helpful to highlight the difference between printing something and returning something, because that's a huge issue that I see with starting programmers. They get those things mixed up a lot. So it's just a fact of life. So like our sum function gives something back, so I can use it in a larger context like this. I can say sum 2, 3 times 2, yeah, because it's going to give back the 5. So it'll get like replaced with 5, and then it'll compute 10. That's pretty cool. That's kind of what I want to have happen. All right, so let's make that function. So we're going to return something. We're going to return a value back from our function, and when that happens, the call gets replaced with the result. All right, then you can work with it. So I'll go back to here. Let's make things that actually make sense now. So, all right, I'd like to make a sum function. Def sum. Maybe I'll put it on this side. That's how I want it to work, right? Sum with 2 values. I'll call those 2 things like x and y, whatever. And so I want to give back the result of adding x to y. That's the whole point of the sum function. All right, so what you do is you say return blah when you want to give back blah. From your function to whoever called you. So I want to compute x plus y, that's my answer, and to give it back, I say return. Return x plus y. Okay? That's what happens. And now I can call my sum 2, 3. Right? I can say sum 2, 3. That'll get replaced with 5. I can do math with that now. I can multiply it by 2 to make 10 or whatever. And then that's computing 10. And if I want to see that, I better print it. Right? It's just like any other math function now. It's giving an answer back to me. That's a very, very important fact. Right? So there it is. Oh, I better print a new space, shouldn't I? How do I want to do that? Dun, dun, dun. Let's do that here. Just print an empty line just to show you the differences there. So it's there's the 10. See how I'm printing the result of sum 2, 3 times 2. Giving the answer back, and so I can use it in a larger context like with the star and with the print. Okay? Again, because this is a function that gives something back, I can't use it like this one that just went off and did something for me. I can't call it on a line by itself. If I said sum 5, 10, for example, on a line by itself, I will see nothing at all. I still have the 10 from before, though. I see no output here because, again, it's giving the answer 15 back, but we're not using that result. You kind of see what's going on there? So we're not doing anything with this result. We're computing it. The computer is getting a little bit hotter because we asked it to do this, but it was all for nothing. Okay? Not doing anything with the result. And so what you need to do is you say, compute the answer and like shove it into a variable so I can use it later. Or print that result immediately. That's the key difference between a function that returns something and a function that is just meant to be called on a line by itself and goes off and does something for us. So there it is, getting us our 15. Right? Are there any questions about the difference? between our sum and our print from 1, 2. So there's no return in print from 1, 2. So it goes off and does something for us. Meant to be called alone. But sum returns, gives an answer back. It's meant to be called in a larger context. If you can't call it alone, it makes no sense to do that. All right. How do I want to show this to you? So it's a very common error that I see in CSCI 1 and CSCI 40 of instead of returning something, we interact with our computers mostly by printing when we write programs. So a lot of us think that like printing and returning are like one and the same. So they are not, and I want to show you an example of that so that when this happens to you, it will inevitably happen to you, this error. And so I want you to just understand what went wrong. All right, so yeah. When you don't return from your function, if you just print inside of your function, for example, you can't use the result in any way. You can only call it on a line by itself. All right, so here is, let me take my sum function and make an incorrect version of it. All right, so here's my normal sum function. Here it is, sum xy. I'm going to make a bad version of it. All right, here it is. I'll call it sum bad xy. And instead of returning x plus y, I'm going to say print x plus y. Because I'm making the error of confusing returning and printing right now. Okay? It's a very common error. So this function is wrong. It's not going to do the summing that you expect it to. It's just printing. All right? It's not giving back the answer. So do we all see the difference between this sum and this sum? One's returning, one's printing. They're returning / printing the same thing though. And so you might expect to be able to do this, right? Print sum bad, the result of calling sum bad with like 2 and 3. What do you think this is going to print? You think it'll print 5? Take your bets now. It's going to print 5 and then none. All right? Again, because sum bad does not give anything back. So it results in, it gets replaced with the none, right? That's the default value when a function gives nothing back. And so print, what print sees, it's getting replaced with none. Print kind of sees this after the call completes. It kind of turns into the call to print none. So that's why we see that right after. Are there any questions about that? That's key. All right? And then, in addition to not being able to do that, like, this is what's really going to cause an issue. Like, you want to use it in a larger context for real. Like, it really does give you the 5, but like this, let's do sum bad 4, 5 times 6. This is extra bad, all right? Because it's not giving a value back. It's take your bets as to what's about to happen here. Oops. This will be a runtime error, all right? So this line is very incorrect. What's it trying to do? It's gonna print 9 and then error out. It's gonna stop the program, right? Because let me walk you through what's going on here. So print is trying to print stuff, right? It sees this expression. It's like, all right, I need to print whatever this results in. So it has to go off and compute the result. So it knows what 6 is. It knows how to multiply stuff. The only thing it doesn't know is what the result of this is, because sum bad's just an expression that's not an answer yet. So it goes off and it calls sum bad on 4, 5 first. And that is going to print 9, right? It jumps to this code, prints 9, gives back none, right? So this gets replaced with none. And so this print call, what it sees after that call completes, it's seeing like print, right? The sum bad 4, 5 gets replaced with none. And it's trying to multiply 6 into none. See that? That's the issue there. And so that's, of course, completely nonsensical. And it's going to complain about it. It's like, I don't know how to multiply a none and an int. That was weird. So that's the issue. Okay, so printing, sure, it computes the sum. It will print the answer. But if you want to use it in a larger context, you're out of luck. Because it's giving back nothing. Nothing at all. You can't multiply nothing by something. All right? Are there any questions now between the correct sum that really does give something back, can be used in a larger context, prints nothing, you got to print its result eventually, and then sum bad, which just immediately goes to printing and gives nothing back at all. All right, I'm hitting this hard because this is a very common error. And hopefully you will remember this moment when it happens to you. So, yeah, that's what I wanted to say about all that. I'd like to draw for you now what's going on when those two different functions get called. Why one gives something back and it works, why the other doesn't give it anything back and it doesn't work. All right, I'm going to show you an example of what I call the stack. All right, this is a technical term. It's short for the function call stack. It's like a picture that I'm about to draw that like tells you what's going on when your program gets run. Right? Like I'm going to draw a stack of things, like a stack of papers on a desk, for example. It's going to look like that. And what you do is when you're drawing what's going on inside of your computer and how functions are calling, they get added onto this place whenever they get called. All right, so let me draw a picture for you of the stack. So when we start our program, we're in like the outermost code. Like somebody's calling us, we're in the outermost code. Like that's the first thing that we need to do. That's our first priority. Start running all the outermost code. Okay, and then let's say I want to talk about what's going on when I call this line, print sum 510, right? So what happens is I call print first. Print happens first, so like that's new work I'm pushing onto this thing called the stack. So print is a function that I need to execute, and then print needs to print whatever it's given, and it doesn't know the answer yet. It doesn't know what sum 510 is. Like it doesn't want to print out that exact text. It needs to print out the answer that it gives back. So it needs to go off then and compute the sum of 5 and 10. Right? So print hands off the work to sum 5, 10. And so this is called a stack diagram. And so it kind of shows you where you were. You were in the outermost code, and you called print, and print needed an answer, and it called sum. So all this work is like incomplete so far. And the thing on the top is the thing that's running right now. So sum needs to happen first, give back an answer to print, so that it can print its stuff, and then we can return to the outermost code. All right, that's what I'm showing to you in the stack diagram. And it's very helpful, this diagram, in that it shows you kind of the values of variables as well. So like when you pass something to sum, the variables that live inside of sum, we can put boxes there. Really, I've been drawing boxes out in nowhere land, and I should have been drawing them in a stack diagram. So if I call print sum 510, or this one, sorry, sum 510, we're jumping up to this code with x and y parameters. They're really just variables set to 5 and 10. So sum has an x variable and a y variable, and because of the way I pass things, they're set to 5 and 10 here. See that? So that's a good description of what's going on. It's a nice graphical representation of what's going on when I call this code. All right? I'm in the outermost code. I called print. Print needs the answer from sum first, though. So like sum is the thing on the top of the stack. It's the first thing that needs to get done. You can only pull from the top of the stack for your work to do. And it needs to give its answer back to print, and then print can give back its answer and like return to the outermost code. It's like it's always people below waiting on the people above. Okay. So sum is going to go do its thing. It's going to return an answer of x plus y, which is 15, right? It computes 15. X plus y is 15. X plus y is 15. It's going to compute that and return it back to whoever called it. So this is the kind of picture that I should be showing. And that's what's happening. Like sum is returning its answer to print because that's what it needed to know what to print. So print is seeing the 15 now, and sum's done with its work. So like I should be erasing it, but I'll just draw a slash right now. So now we're back in print. It saw the 15. It sees the 15 now. It got replaced, right? It replaced sum 510 with 15, and it can go and print that out now. Print knows how to do that. So here's like here's like the output screen. So we see 15 in the output, and now print is done with its work. And now we're back in the outermost code. That's like the next thing for us to do, and then we call like print again. All right. So that's kind of an example of the stack diagram. All right. So sum, it shows you who's giving back answers to whom, and just like who's waiting on whom as well. So sum gives back the answer so that the code below it, right, print and like the main code beneath it has access and can use it in a bigger expression. Like think about it here as well. Right. It's giving back again 5 to print so that it can do multiplication before it prints. Right? And then sum bad, what is the stack diagram of that one? So we were in the outermost code. Let's say that we want to draw what's happening on this line right here. Why is it printing the right thing and then none? So we're in the outermost code, just the straight line stuff. And then we called print, right? Print sum bad. So print is the next thing, the next piece of work we need to do. We add it to our stack of work to be done. And then we call sum bad with 2 and 3. So now print needs to go off and compute that. So print is waiting on sum bad. That's the most important thing to do right now. So sum bad is on the top of the stack of work to be done. And it's being given 2 and 3. The 2 and 3 are being placed into the x and y parameters. Those are just variables. So here's x, it's 2, here's y, it's 3. And then it's going to go off and do its work. So sum bad, it calls print. So technically I can add another print call up here, but I'll save that. So it's going to compute 5 and print 5, right? That's what sum bad does. So it prints 5 to the output screen. We see that right now. And then sum bad is done with its work. It's going to give back nothing to whoever called it. All right? Hopefully they're not going to use that. Sum bad results in nothing. It returns nothing at all, so it returns the special value called none to whoever called it, and now it's done with its work. So now we're back here. Print sees the result of none, so it's like, all right, that must be what you wanted to print. So now it prints the none. See that? And then now print has done its job. Like, I printed the thing you wanted me to print. So now we're back in the outermost code, ready to run more lines of stuff. All right? So do you see the key difference here? Like, this one gave something back to the print. This one gave nothing back to the print. So I'll draw more of these pictures later, but that's kind of like the start of it all. All right. Yeah, I think that's what I wanted to say. If we're good. Any questions about this? This is a very complicated topic, I know, but it's useful to have it be explained to you once, so you can come back to it later. So there's all that. Let's have some more examples. Let's make a function that sums up all the numbers from 1 to n and gives it back. All right, let's have it give it back. So I want to make a function like this, sum1, 2, and I'll call it like this. I'll say sum, that's how I want to use it. Sum1, 2, let's say like 5 or something. So I pass the 5. That should go off and compute 1 plus 2 plus 3 plus 4 plus 5, yeah? Which is 9, 10, 15. So it should give back the answer of 15 whenever I call it like that, okay? So let's do it with a while loop this time, just to remember what while loops are all about, but here's kind of what it's going to work like. So sum to 1 to 5, we get a number. We'll call that number n. We want to calculate a sum. We'll start it at 0, loop through all the numbers I need to loop through, right? And then I'll give back the answer that was in the sum variable. That should hopefully hold 15 if n was 5. Okay? So that's the goal. And the whole point of being able to return stuff is so that I can use it in a larger context. I can say sum 1 to 5 and like multiply that by 3 or something. That's the whole goal here. This will result in, right, if it returns something back, this will be replaced essentially with the 15 that it results in. And then we can compute 45 by multiplying it, because we have all those things at our disposal. Okay? So yeah, how are we going to calculate the sum? It's like somebody gave us the n was 5 or something. I think a good way to do it would be to like set an iteration variable, start it at 1, right? And then keep on, like we have our sum variable set to 0. I'll just keep on adding into the sum variable. We know how to do that, right? I just want to write this in a legible way, though. And so, like, I'll add in the 1 into sum, and then I'll make I 2. And I'll add in the 2, the I into sum now. Now sum is 3, make I 3. See that? That's what I want to be able to do. Add in the 3 into sum, now it's 6, make I 4. Add in the 4 into sum, now it's 10, da-da-da. Okay, da-da-da, da-da-da. That's how I want to do that. And then sum will hold the right value if I iterate through the right things. So how do we calculate that sum? How do I spell that out? It's like, well, start I at 1. We'll use a while loop this time. So I want to iterate through the numbers 1 through n. So 1 is included and n is also included. So while I is less than or equal to n, right? That's our way of iterating. I will add the value of I into sum. So sum gets to change, right? Sum should change to whatever it was before, plus I tacked onto it. And then I just added 1 maybe. I want to add 2 next, 3 after that. So I want to increment I. I equals I plus 1. So that's going to be my code. So let's write that up. So I'll make a new file called sum functions.py. And so let's code exactly what we just had there. So I want to be able to say something like this. Print, like I want to calculate sum 1 to 5, multiply the answer by 3, and like print all that out. So all right, let's do it. def sum 1, 2, parameter is called n, that's the thing I'm given. It could be 5, for example. I want to start my sum at 0, do my work, and then sum will hold the right answer, so I'll return whatever was in the sum variable. Okay. So what do I do to increment sum to the right stuff? I want to start an iteration variable at 1, because I want to loop from 1 to n. So while I is less than or equal to n, I will have a chance at being 1, 2, 3, all the way to n. Add I into sum, and advance I to be the next number I want to add in. Right? Eventually it'll become so big it stops, and everybody's happy. So that is the program, and here is the output. Correctly 45. It's going to do the right thing no matter what, however you call it. Okay? So any questions about this code? Why it's doing the right thing? It's going to compute the sum of all the numbers from 1 to that number, and it will give it back so you can use it in a larger context, which is great. Returning is important. All right, so if we are happy, now it's your turn. I've given you a lot of information. I had to give you all this information before I could ask you something, but now I can ask you something. So please, let's go to the written nice page, why not? And please do attendance by the time the question is over. But help each other. You guys can just type in one place, it's fine. But see if you can get it working. Instead of making a sum 1 to n function that gives back the sum of all the numbers from 1 to n, right? Change this around a little bit to make a sum odd 1, 2 function that gives back the sum of only the odd numbers from 1 to n. See the difference there? It's like if you call sum odd 1, 2 with 7, it should give back the result of adding 1 plus 3 plus 5 plus 7. See the difference there? And what is this? It's apparently 8 plus 7 is 15, 16? 16 as the answer, okay? So how would you change this? Make a new function, try using it, see if it's going to compute the right thing for 7 and other values as well, okay? Any questions about the question? All right, go off and help each other, and I'll be here to help too, but give that a try. It's a really good practice, I think. Make your own function. So now it's named. You can do plus equals. You just can't do plus plus. All right, another minute or so to work. Let's see if we can change it properly. Almost the same, just a different name, of course. And it's going to work slightly differently. So how do you separate the 1, 2, 3 from the 1, 3, 5, dot, dot, dot? And that's the key. All right. Any brave souls care to show their answer? Nice. It looks like maybe the written nice page messed things up. The indentation, but that seems about right. Yeah, I see 2s instead. That's going to be the answer. Good. I promised to end that. So yeah, nice. Maybe we were almost there. We were afraid to press submit, but that's all right. Let's look at the difference. Really, it's like the thing that was the issue. The only difference was like we went from 1 to 2 before, right? We want to go from 1 to 2, then to 3, then to 4. We want to go from 1 to 3 to 5 to 7. So instead of adding 1 every time, we're going to add 2. And that'll make all the difference. There is like an edge case of like what happens if you say sum odd 1 to 8. Depends on what you want to have happen there. Like it'll still compute the sum from 1 to 7 because it's like while it's less than. So it'll still work just fine. I think that's the way you want it to work anyway, but it's up to you. How you want to handle even numbers. Maybe you could yell at the user with an if statement, just like give back nothing. But it is up to you. Let's see. So yeah, let's take a look. I would like to make a new function, and I'll call it sum odd 1, 2. And instead of going up by 1 each time, I'll go up by 2 each time. Right? And so like each of these, like this one gives back the last sum, give back the final sum there. It's the sum of all the numbers from 1 to n. And then this one's going to be the sum of all the odd numbers from 1 to n still. Okay? So there it goes. And now we can call it and see if it works. So print sum odd 1, 2, like 7. That should hopefully compute 16. And the goal is to have that output and also have it be returned properly so that I can use it in a larger context. I can say like, take that answer, multiply it by 2. Something like that, okay? And so that's, now I see 32 as the output. And again, there are some things that are implementation decisions that you could make, like what do you want to have happen when it's going to sum all the odd numbers from 1 to 8? Like the way the loop's going to work is it's going to go, all right, let's see. If you call sum odd 1 to 8, I is going to start at 1, of course. So it should give back 1 plus, and that's 3, right? 3 is still less than 8, plus 5, because 5 is still less than 8, plus 7, because 7 is still less than 8, and then it'll compute 9, right? And then it'll stop the loop. So, actually, this will still compute 1 plus 3 plus 5 plus 7, even if you call it with 8. And maybe that's what you wanted to have happen anyway. It's like all the odd numbers up to 8, still 7. That'll still work like that and give back the same answer, but it's up to you how you want to deal with that. Maybe you could consider if the input was not odd itself, maybe that should be an error or something. I don't know. Up to you. Up to you, though. Any questions about that and how to get it from the original function? Can I show them both at the same time? Yeah, just really a one-line difference there. All right, so yeah, like I've tried to show you, like functions are amazing because you can call them a bunch of times in a bunch of different places. That lets you reuse your code. You don't have to copy and paste it a bunch of times. It's really nice. So functions are amazing. You should use them as much as humanly possible. Okay? So yeah, I think the last thing I wanted to say about functions, or just about programming today, I want to teach you the difference between, now that we have functions, we have a different kind of variable that I've told you about secretly. There's a difference between a variable that's defined outside of a function and a variable that's defined inside of a function. And they're called global variables and local variables. Okay, so if you make a variable outside of a function, it's called a global variable, and everybody has access to it, even the functions. Okay. If you make a variable inside of a function, though, it's called a local variable, and it lives only for, just like a parameter, it lives only for the life of that function, and only the function itself can use it. So parameters are local variables, technically. And then if you want to mess with a global variable inside of a function and like change it rather than just use the value, you have to do something special, and I'll get into that in a second. Okay, so let's talk about the difference between globals and locals, now that we know a way to get at the difference. Locals versus globals. It's a different kind of variable that we have inside of a function. All right, so if I just say x equals 42, like this is the kind of variable we've made already, we know how to do that. This is actually called a global variable. All right, so this is a global variable. It is visible to everybody. You can use it inside of any loop, inside of any function. It's there. Everybody has access to it. It's universal, global. All right. So of course you can say print x. Everybody knows about it. It's there. It's happy. Okay. So that's an example of a global variable. It's fine. But if you do this, if you say, let me make a function. I'll call it blah, my easy function name. I can use x inside of a function, right? Because x is a global variable. It's fine. It exists everywhere. I can say print x times 2. Okay, that's fine. So x totally exists in here. X exists in here because it's global. It exists everywhere. That's pretty nice. Though, I can make a variable inside the function as well. And I can make a variable called y. Let's set that to 3. So this is a local variable. It's only going to live for the life of the function, and it's going to go away when the function returns to whoever called it. So I can use it still here inside the function. I can say print y times 2. It's happy. It's fine. And I can call blah. So see if you can try to just take a few seconds to look at this code and try to predict the output. That's a really good practice, I think. See if you can figure out what's going to happen here. (42 times 2 is 84. Here's what we see here. So, all right, first line is that does anything is print x. Then the definition of the function is just like information for later. You have to call the function to actually go there. So then we call blah, and we print x times 2. X exists everywhere, so we get the R84 printed. And then y is 3 here, and we print y times 2, so that's 6. That's perfect. All right. So one thing you cannot do is print y outside of the function, right? Because y was a local variable. This line right here won't work. It'll give me an error. It'll give me the previous output, and then it'll give me an error because it's like y is not defined. Y goes away the second blah is done. Okay, that's what I want to tell you. And then let's see. The last thing I want to show to you is, for a weird reason, you can't do this. You can't say x equals x plus 1 inside of a function. You can't mess with. You can use a global variable inside of a function, but you cannot mess with it because then it thinks you're trying to make a local variable the second you create something. So if you want to yell at Python and say, no, I would like to mess with a global variable right now with this line, not create a brand new local variable, you do this. If you have a function, you want to set a global variable, you have to say global, name of that variable on a line by itself, usually at the start of the function. So that's the last piece of the puzzle here that I want to tell you about. So if I want to run this line and have it affect this x, I have to say global x. All right? So this tells Python, I want to modify. I want to modify the global variable x, not create a brand new local variable also called x. Because you could do that. That's what the line would do otherwise. Okay? So that's what you got to do there. And now, what's our output? It's going to be slightly different, because now x has been added to stuff. Let's see here. So I see my 42 printed, and now it's not 84, it's 86 printed out. See that? And then so I still have that, and I still have my error because y stops existing the second blah is done. Okay? So let me draw for you a stack diagram as to why we see these things happening. So let me draw a stack diagram for the entire program running. All right, so when the program begins its life, we start just in the outermost code, just the straight line stuff, just like this one. So we start in our outermost code. Whee. And the very first thing we do that's useful is to make a variable x called holding 42. So it's part of global thing, so it lives in the outermost code. So like this is where I draw the box in the stack diagram. It's part of the outermost code x. That's where global variables live. So there's x, holds 42. And then I print x, and so we see our 42 printed out. Right? That was the first thing that we see. There was my 42 printed on the screen there. And then we define blah, so we can use it later. And then we call blah. All right, so we call blah. We have to go and do its computation. So the outermost code goes and calls blah, just like it calls print. So we call blah. What does it do? It advances x. It makes x plus 1 because it marks it as global. It's like, all right, I want to modify the global variable x. That's the part of the outermost code, so it makes x 43. That does that line. And then it prints x times 2. You can imagine it's going to call print, compute that thing, and it's going to print 86. That's what we see next, because 43 times 2 is 86. And then it creates a new variable local to blah called y, holding 3, and this is where I draw that box. This is y. It's how you represent the fact that it belongs to blah, and that's why it's going to go away later. Right? So there's y holding 3, and then we're going to print y times 2, so like we call print. It gets past 6, and it prints the 6. Right? And then we're done with blah. So the second we're done with blah, it gives back none, remember. It gives back nothing to whoever called it. They were looking at what it gives back, but we're not. And now we're back in the outermost code, and we try to print y, but you see how there is no box that lives in the outermost code. There's no global thing that is called y. The y that was part of blah went away when blah went away, when it was done with its work. All right? So that's why we get an error now, and this line just causes the world to blow up. Okay? Any questions about that? Does that, hopefully the diagram helps a little bit. I'll draw more of these now that we have functions at our disposal. That's kind of why. So that's a local variable. Variables that are part of functions are called local variables. Variables outside are called global variables. Everybody gets access to them. But functions get to have their own. So you could have made your own x variable inside of blah, and it would have been separate from the outer x. So that's weird. I don't recommend it, but it's possible. Okay. So yeah, a lot of new information today. Very useful stuff, I think. And that's our first taste of functions. So if we're good, let me release one last thing. This will be the very last day of classes. Not the last day of finals week, but the last day of classes, May 10th. Here we are, exactly a month away. So that's going to be the Friday. May 10th is the last day of classes. Finals week is the week after that. So this is worth up to another 5% extra credit if you'd like to do it. So this is what I want you to do if you'd like this extra credit and have this opportunity. So I'd like you to make a review video, all right? So I'm going to test you on Python on the final exam, okay? I couldn't have tested you on Scratch because like you have to take screenshots. It would have been weird. It's very easy for you to type Python code into Canvas. So expect to do that on the final, all right? So I will be asking you about Python, and I'll be like drawing questions from the stuff I've been showing you in class and the programs I've been asking you to write. So I'd like you to make a review video reviewing Python to help yourself study for the final and to also help your peers. So the way that you can submit your answers, you just click reply down here, right? And then you can submit a video, and then everybody is allowed to see it. That's why I made it a Canvas discussion. So like it's you helping everybody. Your peers are going to love you if you do this. And here are your requirements for that Python review video, all right? So just pretend to be a teacher maybe. Make a bunch of examples of Python concepts that we've talked about. Don't just like copy my stuff though. You have to make your own new demonstrations and examples. Okay, so be creative. The one thing you can't do is just like read my slides again, right? Don't like go over an assignment you've already done. You have to do something extra. Keep that in mind. So just don't copy anything I did in lecture you've already done. And and just like go through stuff, demonstrate, explain the concepts you're trying to review for the exam for Python. A good example would be like to pretend you're a teacher giving a lecture like me. And so if you want half the extra credit, you should make at least a 15-minute video talking about Python stuff, maybe like drawing examples, drawing pictures of how it's working, and like giving input and outputs and like writing code. If you want the full 5%, please make at least a 30-minute video, okay? So that's what I want to see there. And just like make sure you can ask me if you have any questions. I highly encourage you to ask me if you're not sure if your idea is good enough to receive credit, all right? So I just need to make sure that you know that you have to make something new. You have to do something extra to receive the extra credit. You got to make new code, write new code, make some new slides, make some new diagrams, stuff like that, all right? So I want to make sure you get your credit, so make sure that you're doing something different and ask me if you are at all confused or have any questions, okay? So those are the hard requirements. Yeah, just make a review video about Python with some unique examples. Questions about that? So yeah, feel free to do that if you're interested. And I assume you know how to record yourself by now, but I'm happy to help if you're having trouble with anything. Yeah, so let's do the last day of classes. Do it if you want to. No late submissions. This will be due at midnight on that day, 11:59. Okay, so that's your Python review extra credit opportunity. And if we are good, if there are no questions, I think that's everything I wanted to say for the day.